Hi all. Today we are going to discuss about the phase diagram. We have already discussed the phase diagram is a map that shows which phase is the most stable at different pressure and temperature. The phase diagram is a plot showing the conditions of pressure and temperature under which two or more physical states can exist together in a state of dynamic equilibrium. Here the phase diagram of water is shown. Here only one substance is there in the phase diagram. So you can say that it is a one component system. If you take any phase diagram, it has got three characteristics. The very first characteristic it is the region or areas. So if you look at the phase diagram, this is what the phase diagram of water. You could see a solid yellow line. There are three yellow lines, could be read as OB, OC, OA. So these three lines divide the graph into three regions, and each region represents a phase of that component. And the second point is lines or curve. What does this line represents? The lines separating the region or the area in a phase diagram are called phase boundaries. At any point on a boundary between two regions, the two neighboring phases coexist in dynamic equilibrium. If one of the phases is vapor, the pressure corresponding to this equilibrium is just vapor pressure of that substance. Therefore, the liquid vapor phase boundary shows how the vapor pressure of the liquid varies with the temperature. And what is this vapor pressure? What is this vapor pressure of a liquid? Vapor pressure of a liquid. For example, you are taking a liquid in a container. So this could be the container. It's a closed container. This container is having a speciality. It is connected with a barometer. It is connected with a barometer. Barometer is the device by which we measure the pressure of something. So here, inside this container, there is nothing. When there is nothing, the pressure will be zero. So what I did is, I have added a little substance which is in the liquid form. I just added, then you could see the pressure will be zero. Then I just added, you could see that the barometer, inside the barometer, the pressure level will be increasing slowly. How does it increases? When there is a liquid, you know that there is a process called vaporization. Vaporization is a process. The molecule at the surface of a liquid will have a tendency to get up and move away from the liquid surface, so that some of the molecules of the liquid will be getting escaped from the bulk of the liquid. So this is what we call vaporization. There is another point is what we call boiling. So what is boiling? How do you connect vaporization with boiling? So vaporization means, so here also vaporization happens. Some of the molecule from the liquid state will be moving towards the empty space. So what happens? The vapor molecule will be roaming around over here. So when the vapor molecule is increasing, what happens? The space over here is occupied by the vapor molecule, so that the pressure increases. Pressure will be slightly increasing. And there is a point, it is related to physical equilibria. What is that point, if you ask? When there is sufficient amount of vaporization happens, need not be, it depends on the nature of the liquid, the process happens in the reverse direction also. When the process happens, that is the conversion of the molecule from the liquid state to vapor state, is what we call vaporization. But when it happens in the opposite direction, we call it as condensation. So we wanted to discuss about what is that vapor pressure. So what happens is, slightly vaporization starts, and after a particular instant the condensation also starts, and these processes will be increasing by the passage of time, and they wanted to equilibrate with the room temperature or the condition which exists at that point of time. So what happens? The pressure will be increasing, keep on increasing until there exists an equilibrium between the vaporization and condensation. So when there is an equilibrium, we already know what is equilibrium. Equilibrium is a state at which the rate of the forward reaction as well as the backward reaction, which is the part of the reversible reaction, will become exactly equal. Once it becomes exactly equal, we call it as the process is at dynamic equilibrium. So please understand, equilibrium means it's not going to stop the reaction. The reaction is not in static condition, it is in dynamic condition. That means the forward reaction is happening as well as the backward reaction is happening. Initially, when the vaporization was more, that is the forward reaction, vaporization is more and the condensation is less. Now we say that the equilibrium is established. That means the rate of the vaporization and the rate of the condensation is exactly same. So the rate of the forward reaction is exactly same to the rate of backward reaction, so that the system is at dynamic equilibrium. So when it is at dynamic equilibrium, whatever be the number of molecules of the substance are at the vapor state, and the number of molecules of the substance are at the liquid state will not change, that will be constant. When that will be constant, you can't expect any more increase in the pressure, and the pressure will become constant. When there exists an equilibrium, the pressure due to the, what is this pressure due to? The pressure is due to the vapors exerted by the pressure exerted by the vapors, and it has become constant. So at that constant condition, the vapor pressure, the pressure exerted by the vapors is what we call vapor pressure of the liquid. So vapor pressure of the liquid is the characteristics of the equilibrium between the vapors and the liquids of a substance. So hope you understood what is vapor pressure. So vapor pressure means it is the pressure exerted by a liquid at certain temperature when it is taken in a closed vessel. So you can have any, you can have kerosene, you can have water, you can have any oil, you can have petrol. For all of them, at a particular temperature, the pressure due to the vapors, that is the vapor pressure, will be constant. That is what we call vapor pressure. So please recall, Please recall, the lines separating the region in the phase diagram are called phase boundaries. At any point on the boundary between two regions, the two neighboring phase, for example, this two phases, this is liquid and this is vapor, they coexist in equilibrium. If one of the phase is a vapor, the pressure corresponding to this equilibrium is just the vapor pressure of the substance. Therefore, the liquid vapor phase boundary shows how the vapor pressure of the liquid varies with temperature. So here this is the temperature and this is the pressure as mentioned. And the third characteristics of this phase diagram is a point where three phases, the boundaries of three phases meet on a point. So a triple point is a point where three phase boundaries meet on a phase diagram. For water, the triple point for the solid, liquid and vapor phase lies in torr, if you say, for 0.6 torr and 0.01 degree Celsius. We'll talk about it. Now let's talk about the region or areas. The diagram is divided into three regions or areas which are labeled as solid, liquid and vapor. Any point in the region marked as solid or specifically as ice in case of water corresponds to conditions for which the solid phase of the substance is most stable. Similarly, the region marked as liquid and vapor, or it could be gas, indicate the conditions under which liquid and vapor respectively. The areas in the figure, as I have discussed, are COB, COA and AOB. Each of these three areas shows the conditions of the temperature and pressure under which the respective phase can exist. Applying the phase rule to the system, I am talking about the area or region. When only one phase is present, we have, if you apply the phase rule, do you recall the phase rule? If the equilibrium between any numbers of the phase is not influenced by gravitational, electrical or magnetic force but is influenced by pressure, temperature and concentration, then the number of degrees of freedom, that is F, is related to the number of components, that is C, and the number of phases, that is P. The equation is given as F is equal to C minus P plus 2. So here C, number of component, it is 1. Number of phase, it is only 1. See, when your region or areas, we are not talking about all the areas, we are taking one area. So 1 phase and plus 2. So the number of variables means like pressure, temperature, required to describe if a region or an area is equal to 2. So if they are asking to write down the characteristics of phase diagram, you have to draw a phase diagram. Typically we generally used to draw water. So you have to specify what are the characteristics of a phase diagram. They are regions or areas, lines or curves, and point like triple points. So we are talking about areas and region. So we already told about areas and region. Here we have taken water as an example. There are 3 regions. And next, lines or curves. There are three lines or the curves separating the regions or areas. These curves show the conditions of equilibrium between any two of the three phases. That could be solid or liquid or vapor. Means the line is between the solid state and liquid state. The line could be between the liquid state and vapor state, and the line could be between the solid state and vapor state. Tell me, what is the line which represent between the solid and liquid by looking at the diagram? Tell me which is the line that represent between the solid and vapor. Tell me the line which represent liquid and vapor and solid and vapor. Just name it. OB, OA, OC. Three lines are present over here. Now the solid liquid line is what we call OC, which represents the equilibrium between the solid and liquid. OC, solid and liquid, is referred to as the melting curve or fusion curve. Liquid or vapor line, that is OA, which represents the liquid equilibrium liquid vapor, is referred as to the vapor pressure curve or vaporization curve for the liquid. Next, solid vapor line, that is OB, which represents the equilibrium of between the solid and vapor, and it is referred to as the sublimation curve. Whatever you talk in terms of phase diagram, whatever be the point you are talking something related to the phase diagram, you are bound to apply the phase rule and say how many variables are required in order to represent this particular region or the curve or the point. So here we are talking about the curve. So applying the phase rule to the one component two phase system, that is F is equal to C minus P plus 2, 1 minus 2, because when you talk about a curve, the curve comes as the boundary between two phases. So the curve talk about two phases, whereas the region talk about a single phase. So here when the curve talk about two phases, the equation will be 1 minus 2 plus 2, that is equal to 1. So if you talk about, for example, if you talk about the pressure, line is not correctly straight. If you talk about the pressure over here, you already told about the temperature. So if you are talking about the temperature over here, you even told about the pressure. That means if you talk about one variable, the other variable is revealed automatically. So the curve is required only one variable in order to represent the state of the system. So please understand, applying the phase rule to one component two phase system, the degree of freedom is equal to 1. This phase rule predict that the two phase equilibria state above will have 1 degree of freedom. It need only 1 degree of freedom. And the third point is triple point. Triple point means the three boundary lines enclosing the three areas on the phase diagram intersect at a common point called the triple point. A triple point shows the condition under which all the three phases, that is solid, liquid and vapor, can coexist in equilibrium. Thus the system at the triple point may be represented as, so in the at the triple point there are three equilibriums coexisting together, that is the solid state of water, liquid state of water and vapor state of water. All are coexisting at this point. So a triple point is a point where three phase boundaries meet on the phase diagram.